The next topic is combinations with repetition. Okay. Now see, there are five objects A, B, C, D, E, and if you want to select any three objects, let this objects be persons. So we can select A, B, and C. Okay. Arrangement is not important. This is pure selection. Now, can we select A multiple times? The answer is no, because A is only one person. Okay. So here we cannot repeat. But then, for example, there are five different categories of chocolates. Okay. And we want to select any three chocolates. So the chocolates can get repeated. A person can opt for two A's and one D or all three A's. Right? So here combination with repetition comes into picture. Fine. So yes, there are seven exercise nine. Prior to that, I'll just give you the formula. If there are n objects, n different objects, our selections are supposed to be made. Okay. In such a way that an object can be selected any number of times. Okay. An object can be selected any number of times. So the formula becomes n plus r minus 1 c r. N plus 1, n plus r minus 1 c r. Exercise number 9, question number 1 from your worksheet. There are seven different ice cream flavors. So n is equal to 7. Okay. And we need to select any 4 scoops. Okay. Now a flavor can be repeated by a person if a random person has a choice of only one flavor. So we'll order all 4 of the same flavor also, or 3 from one flavor and 1 from other flavor out of 7. Okay, so this is combination with repetition. You can use this formula. So this is 7 plus 4, 11, 11 minus 1, 10, C, 4. That is the answer. Okay. Second problem. So guys, second and third problem is based on the similar concept. You can, read the problem and solve it for practice. Okay. Now the next concept. Okay. This is a very important recording, I should say. Now, out of n objects, any number of objects are to be selected. Okay. So out of n objects, we can select 0 number of objects, 1 object, 2 object, 3, dot, 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 till all n objects. Out of n objects, any number of objects can be selected. The combinations will be, the total number of selections will be 2 raised to n. Any number of objects can be selected. And the second case is, out of n objects, at least one object is supposed to be selected, one or more than one. So in this particular case, 0 will not be included. That is, there you cannot make 0 selections. You have to make at least one selection. So in this case, the answer will be 2 raised to n minus 1. So there are some problems based on this. Let us start. Exercise number 9. Question number 4, sub question 1. So there are 5 friends. A man is having 5 friends. He has to invite one or more of his friends to a dinner. So how many ways this can be done? One or more means at least one has to be, invited for a dinner. So the answer will be 2 raised to n minus 1. So that is 2 raised to 5 minus 1, which is equal to 31 ways. Okay. Sub question 2. We are using the second formula because at least one or more means at least one object should be there. In this case, the object is a person. In order to pass an examination, minimum marks are to be secured in each of the 7 subjects. So there are total 7 subjects, and to pass the examination, the student has to pass in each and every paper. He cannot fail. Okay. So they are asking in how many ways a student can fail. So if we consider this zero, that means he is not failing in any papers. If we are considering one, that means the student is failing in one paper, two, two papers, till 7 papers. So if he is failing in one paper or two paper or three paper or dot 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 till 7 papers, all 7 papers, the person will fail. But then zero cannot be included. He cannot fail in 0 papers. A student has to fail, so he can fail from one paper to 7 papers. The number of papers can be one or one, two, three, four, five, six, seven. So he cannot fail in 0 papers. If he's failing in 0 papers, that means what is passing, right? That means he's clear in all the subjects. So here also we are going to use this formula 2 raised to n minus 1, 2 raised to 7 minus 1. Okay. Next note. Now there are p objects which are alike. Okay. Q objects that are alike and R objects that are alike. Okay. So if we have to select at least one object, we have to select at least one object. Okay, that means 0 objects cannot be selected. We have to select at least one object. Okay, and P objects are alike, Q objects are alike, R objects are alike. So this can be done in P plus 1, Q plus 1, R plus 1, minus 1 ways. Okay, so this note you need to know. So exercise 9, question number 5. It is based on the similar concept. There are 4 mangoes. So all mangoes are alike. There are 5 oranges, all oranges are alike. And there are 6 apples. All 6 apples are alike. How many selections can be made by taking at least one of them? So same formula. 4 plus 1, 5, 5 plus 1, 6, 6 plus 1, 7, minus 1. Whatever is the answer, that will be the multiplication of all this, minus 1 will be the final answer. Okay. So let's go to the next problem, question number 6. Now there are 3 books on eco. Now these 3 will be 3 different books because they have not mentioned these are 3 same books. Unlike the previous case, mangoes will be same only, but then books may or may not be same. So we cannot consider it to be same. This can be 3 different books on eco, 4 different books on political science, and 5 different books on history. So we need to make the selections in such a way that there will be exactly one on each subject. The first answer is pretty straightforward. 3C1. Out of 3, we need to select anyone, and from 4, we need to select anyone, and history. From 5, we need to select anyone. This is the first answer. Second one. Okay. Now we need to select at least one from each subject. Now we go back to this particular concept. Out of n objects, we need to select at least one. Okay, 2 raised to n minus 1. So for English, it will be, for eco, it will be 2 raised to 3 minus 1. And for political science, it will be 2 raised to 4 minus 1. For history, it will be 2 raised to 5 minus 1. Fine. So that's how you should complete this particular problem. Okay. So basically the next concept is division and distribution or division. A division or distribution. Okay. Now see, basically if there are m plus n objects, and these are different objects, okay, these are not same objects, these are different objects. So m plus n objects are supposed to be divided into two groups, that is group 1 and group 2. Group 1 will get m objects or group 2 will get n objects. So this division can occur in this many number of ways. Okay. Now m plus n objects are supposed to be given to two different persons, such that person 1 will get m objects and person 2 will get n objects. So the distribution formula is this. There is only 1 2 factorial over here. The reason being, the person 1 can also get n objects and the person 2 can also get m objects. So we cannot strike out that particular possibility. So when it is division, you have to not put that 2 factorial, but then for multiplication, you have to put that 2. For distribution, you have to put that 2 factorial. Similarly, there are m plus n plus p objects, different objects, and we have to create 3 unequal groups of m objects, n objects, and r objects. The division formula is written as follows. Okay, it's given over there. And in distribution, just we need to insert that 3 factorial over there. Right? So basically, over here, person 1 can also get n objects. The person 1 can also get 3 r objects. So any person can get any number of objects, right? So that's why 3 factorial over there. So in the worksheet, let's go to question number 7. There are 20 articles and we need to, let's understand whether it is division or distribution. It is packed in 3 parcels. So m is equal to unequal groups. So this is just grouping division, okay? We are not distributing to 3 different persons. Right? So 5 plus 7 plus 8 is 20. So the grouping formula will become 20 factorial upon 5 factorial, 7 factorial into 8 factorial. Had it been distribution to 3 different people, we could have multiplied 3 factorial, but then they are not asking about distribution. Okay, that was question number 7. Question number 8. There are 10 different marbles. Okay. Now it is supposed to be given to 2 different children. Okay, person 1 and person 2. Person 1 gets 3 and person 2 gets, person 1 gets 7 marbles and person 2 gets 3 marbles. So 10 factorial upon 7 factorial into 3 factorial. But then I will multiply by 2 factorial also, because person 1 can also get 3 marbles and person 2 can get 7 marbles. So this is distribution problem. Fine. Okay, so let us go to grouping and distribution of into equal groups. Now this time, in this particular note which I had given you, these were unequal groups, m n unequal groups, m and r, m not equal to n not equal to r. Okay. So now we will consider the possibilities where the number of objects in each group will be same on equal groups. Okay. So now the next example over here is there are 2m number of objects and we need to divide into 2 equal groups. Okay. Or we have to distribute it into 2 different persons, to 2 different persons. So the division formula is written over here and the distribution formula is written. Okay, slight changes are there in the formula. Likewise, if there are 3m objects and we need to distribute in 3 different groups or divide into 3 different groups or distribute to 3 different persons. So the division formula and distribution formula I have written. Okay. So let's go to question number 9 of the worksheet. Question number 9. So now there are 24 different things, and we need to divide these things into 4 heaps so that, okay, so it's only division. Each group will have 6. So it is division into equal groups, not unequal groups. Okay. So the formula over here will be 4m factorial. Okay. M factorial raised to 4 into 4 factorial. The 4m is 24. So 24 factorial. Okay. 4 factorial raised to, sorry, 6 factorial, because each group is having 6, right? Okay. So m is equal to 6. 6 factorial raised to 4 into 4 factorial, right? Had it been distribution to 4 different persons, so this 4 factorial won't come. Fine. I hope you are getting the clarity on this. Question number 10. 20 students to 4 equal groups. So 20 students to 4 equal groups. Each group will have 5. First part of the solution is 20 factorial. This is only grouping. 5 factorial raised to 4 into 4 factorial. Okay. Now, how many ways these students can be sent to different schools? So school 1, school 2, school 3, school 4. Now school 1 can get this 5 specific students. School 1 can also get this particular 5 specific students. Okay, so this second part is distribution. So 20 factorial upon 5 factorial raised to 4. That's it. No 4 factorial because this is distribution into groups. Fine. Let's go to question number 11. In how many ways can a pack of 52 cards be divided equally among 4 players? Now this is distributed to 4 players. 11 of question 1. So this is given to 4 different players. 13 to each player. So this is distribution. 52 factorial upon 13 factorial raised to 4. Correct? Second problem. There are 12 books which are supposed to placed on 3 shelves. So shelf 1, shelf 2, shelf 3. Okay, I'll just write it horizontally. Shelf 1, shelf 2, and shelf 3. 12 books, 4 on each shelf. Okay. So this is distribution. I'll tell you why. Primarily, this is 12 factorial upon 4 factorial the whole cube into, no into, because it is distribution. Okay, fine. So now see why it is distribution, why it is not division. Shelf 1 can get this 4 specific books. Shelf 1 can also get this 4 or also this 4. Likewise for shelf 2 and shelf 3. So we are distributing. We are not dividing and just keeping it aside. We are distributing also. Okay. So that is 12 factorial upon 4 factorial the whole cube. Just a second. Yeah. Correct. Now there is one more concept. The last concept in distribution. Number of ways of distributing n objects. Okay. Now this n objects are identical objects. Previously we were working on different objects. 2 are persons. Okay. In such a way that a person can get any number of objects. Okay, he can get zero objects also. So the formula is n plus r minus 1 cr minus 1, and a person has to get at least one object. At least one object is n minus 1 c r minus 1. So there are two formulae. N objects are given to r persons. This time identical objects, these are same objects, not different objects. So if a person can get any number of objects, person may not even get an object. So this particular formula, and the second case is the person has to get at least one object. So this particular formula. Fine. So let us go to question number 12. Question number 12. What is the number of ways of distributing 8 rupees 10 coins? Now rupees 10 coins, these are identical objects. Okay. So n is equal to 10, r is equal to 3. 3 beggars are there. Have they said a beggar has to get at least one object? The answer is no. So in that case, we'll be using the first formula. Okay. What was the first formula? Just a second, I'll just erase that slide. This formula. Okay. So 12 sub question 1, n is equal to 8, r is equal to 3. So the first formula, n plus r minus 1 c r minus 1. Okay, put the value of n and r. Second one, there are rupees 5 rupee 1 coins. 5 rupee 1 coins. N is equal to 5. And persons are also 5. Again, this formula. Okay, because rupee 1 coins are identical. This node is only for identical objects. Okay, right? Third, there are 5 identical balls. They have to be placed in 3 boxes. Identical objects. Okay, in 3 boxes. No box remains empty. The meaning of no box remains empty is that a box should have at least one ball. So use this formula, the second formula over here. Fine. So that is how we complete this particular exercise and the chapter as well.